We need to start next presentation. Mr. Aytac. Mr. Aytac. Okay, yes. You are here. Okay. Please start and explain your study goals. Our teachers by Kemal Üçüncü together. First slide, you can start. Okay.
Hi everybody. I have two papers. One of them is investigation of the effect of building material selection and design on thermal properties of the oven. Natural and technical drying methods are generally used in drying timber. Although energy is not consumed in natural drying, the drying period is long and timber cannot be dried to the desired result humidity for interiors. Although the lumber can be dried to the desired result, humidity level in technical drying costs are high. The energy used causes environmental problems. The negative effects of intense energy consumption in timber drying on cost and environmental pollution have strengthened the tendency to utilize solar energy. In recent years, drying of timber with solar energy has been studied as an alternative drying method in order to reduce energy costs in drying. For this purpose, various types of solar-powered timber drying furnaces are designed and drying trials are carried out. In most of these studies, it has been concluded that solar furnaces can be used economically if the fuel prices increase and the cost of solar collectors can be reduced. However, little attention has been given to the effect of wall building materials on the temperature regime in these studies. In terms of drying quality, drying temperatures suitable for the properties of the dried timber should be applied. Materials with different thermal capacities create different thermal properties in different designs. Therefore, it is possible to control the course of the temperature distribution in the solar timber drying oven throughout the day with the choice of different building materials and design forms. In solar furnaces, the temperature varies according to solar energy values and shows significant differences throughout the day. During the sunbathing period, the temperature first rises, usually decreases after reaching the maximum value between 12 and 14. The width of the hourly temperature change interval negatively affects the drying time and quality. The specific heat and heat conduction coefficients of the wall materials also have an important effect on the change of furnace temperature. Therefore, by choosing the wall building materials to be used, a more homogeneous distribution of the oven temperature can be reached. The solar furnace taken as a model in a greenhouse-type solar furnace with a lumber capacity of 10 cubic meter and collector area of 60 square meter. 34.5 square meter of the solar collector designed in the position of the roof of the oven has 30 degrees and 25.5 square meter has a slope of 60 degrees. You can see the solar oven. In order to examine the effects of wall designs and materials on temperature regime, 4 types of walls were designed. Trabzon climate conditions and radiation values were taken as based in thermal calculations. You can see from the slide wall design and building materials types, 4 types can see. The furnace temperature was calculated using the thermal equilibrium equation. The second is useful solar radiation entering the oven. Hourly solar radiation values coming to the collector surface are calculated from Trabzon's average irradiance values for many years and given in table. For collector efficiency, 45% values is taken as basis. You can see hourly solar radiation coming to the collector surface in Trabzon and monthly average values of outdoor temperature in table.
Okay.
Table stored heat, lost heat formulations are in slide. Based on the equation given, the following equation is obtained from the oven temperature and other volt type A, B, C, D formulation you can see. Finding and conclusions. The temperature in solar furnaces varies significantly throughout the day due to the reasons such as the constant change of solar energy during the day, the variation by the seasons, and the absence of any at night. With these features, drying in solar ovens can be considered within the concept of batch drying. Although intermittent drying does not have a direct harmful effect on drying quality, continuous and sudden change in temperature may affect the drying quality as well as increase the drying time. Wall materials also have a significant effect on the furnace temperature in solar furnaces. In tables, the annual average hourly temperature distribution, standard deviation, maximum, minimum, and variation interval values are given for wall types and monthly average. Okay. And monthly temperature average and standard deviation values of furnace types in table. Average oven temperatures has the highest value in A-type oven and the lowest in C-type oven. In A-type oven, the highest value of the average oven temperature during the day occurred in July with 41 centigrade degrees, and the lowest value occurred in January with 17 centigrade degrees. The same values in EC and D type furnaces you can see. Standard deviation also increased in high temperature average values. The largest standard deviation was observed in A-type furnace and the smallest standard deviation in C-type furnace. Hourly temperature distribution according to wall types is shown in figure. These materials with high thermal capacity will store a lot of heat. Furnace temperature in furnaces may despite the low temperatures that occur in the oven during the sunbathing period, the temperature drop is less after the end of sunbathing and at night. In furnaces built of materials with low thermal capacity, the temperature of the furnace, which is higher during the sunbathing period, is greater at night. Accordingly, although the average temperature is lower in furnaces built from materials with high thermal capacity, variation interval and standard deviation are also small, so they may have more positive effect on the drying quality. This type of furnace has more suitable features in terms of ensuring homogeneous and high quality drying. In solar systems where high temperatures are desired during the sunshine period, the selection of low thermal capacity building materials can be recommended. However, it will be beneficial to use material with higher thermal capacity in solar furnaces where activity is desired throughout the day. According to the theoretical calculations made, it's seen that more stable temperature values will be formed in solar furnaces built from C and D type walls. In solar furnaces, thermal insulation thickness of 5 cm is taken as a basis instead of 8 cm thermal insulation thickness recommended in the literature, since the heat losses caused by air renewal are more effective than the thermal conductivity of woven materials. For the same reasons, it is possible to use polyurethane or styrofoam for thermal insulation. The effect of thermal capacity on temperature can be changed by making the thermal insulation close to or far from the inner surface. Thanks for listening.
Okay. Thank you, Mr. Aytac, and for nice presentation.